Factorizing the difference of squares. Now before you start attempting these problems, this is the general rule and you need to know this out of your head. So if you don't know this, write it down, learn it. Right, x squared minus y squared factorizes into two brackets, x minus y, x plus y. And what this implies is, first of all, my question will have two squared numbers like this, which has a minus sign in between them, and then I take the square root of both numbers. The square root of x squared is x, and the square root of 9 is 3, and I put that in brackets with a minus and a plus. Doesn't matter if you put minus plus or plus minus, same thing. The custom all over the world is to put the minus in this particular problem, to put the minus first, but really if you do change it, it's not gonna be a problem. Right, so if I have x to the power of 4 minus 1, what I would do if I have even number exponents, to get the square root of that, I just divide by 2. So I will have x squared, and the square root of 1 is 1, and x squared plus 1, so x squared minus 1, x squared plus 1. But now have a careful look at this bracket. Can you see that this is also the difference of two squared numbers, because x is squared and 1 is a squared number. I can say 1 times 1 is 1, so that makes it squared. I don't have a rule for sum of squares, so this bracket I can't do anything with, but this bracket I can still factorize into, see what happens. This bracket factorizes into x minus 1, x plus 1, and this bracket, please don't forget it, stays the same. So this bracket here becomes x minus 1, x plus 1, and then this bracket just stays the same, and please don't forget to just write it there. Okay, so say for instance I have x to the power of 6 minus 16. Now I've said here, all even numbered exponents, I can get the square root of that by just dividing the exponent with 2. So this becomes x to the power of 3 minus 4, x to the power of 3 plus 4. Now can you see that 4 is still a squared number, but x to the power of 3 is not. So since this is not a squared number anymore, now I'm done. Although there is a negative and 1 squared number, and I don't have a rule for sum, so I'm not going to use that anymore also. Let's look at another example. Say for instance I have 64x squared minus, let's say 121 y squared z to the power of 4. So what I want to do with this is I want to get the square root of all of these things. So I'm just going to focus on that quickly for my first bracket. The square root of 64 is 8. The square root of x squared is x. The square root of 121 is 11. The square root of y squared is y. And the square root of z to the power of 4 is z squared. And then I'm going to put this in a bracket with a minus and a plus. So I'm just going to copy the 8x and the 11yz squared there. This is about how difficult I can make it for you with difference of squares, is they just add a lot of things, or they do what they did here, that after you use the rule for difference of squares, some of the brackets can still factorize even further, but this is about how difficult. This is probably one of the more difficult types of questions that they can ask you, where there's so many things that you have to get the square root of. But if you do that without a problem, then you're fine. I'm just going to quickly run you through this again and write it a little bit bigger so that all of you can see properly. I don't know if you could see that first one. The square root of 64 is 8. The square root of x squared is x. The square root of 121 is 11. The square root of y squared is y. And the square root of z to the power of 4 is z to the power of 2. And then I just write this 8x that stands there and 11yz squared. I'm just going to write in both brackets with a minus in a plus, and then I'm done. Let's quickly look at an example like this where I can multiply, factorize further. That does this a few times. They like to ask this for the grade 10s, grade 9s and 10s. I doubt whether they'll ask something like this for you in grade 12, but I'm sure if you can do this in grade 11 and 12, then you know, okay, I'm fine with this type of questions. If you can repeat this just a little bit for yourself, and then it drills in the formula also. Say for instance I have x to the power of 8 minus 1. Now this can factorize, I halve that. So this can factorize into x to the power of 4 minus 1, x to the power of 4 plus 1. Don't get confused between the square root of numbers and the square root of exponents. The square root of numbers still work like they always did. The square root of exponents you halve. Don't go and halve a number just when it's in the exponent. And then this one, can you see, can still factorize further, and I can halve it again into x squared minus 1, and then also x squared plus 1. These two brackets are that one factorized, and then don't forget to write this bracket there. Okay, and then this is sum of squares, but this one is still difference of squares, so this one can go further into x minus 1, x plus 1. Can you see that this is that bracket? And then don't forget to write these two brackets to just carry them over. So I have x squared plus 1 and x to the power of 4 plus 1, and now there's nothing that can still factorize anymore, so then I'm done. Right, let's quickly look at something where they use 9x to the power of 6 minus 25 y to the power of 8, where they use numbers and variables. Then I just take the numbers and the variables and see the square root of 9, what I said there now, don't get confused. The square root of 9 is 3. For numbers I take the square root as usual, but the square root of x to the power of 6, because it's an exponent, I halve the exponent. And then for 25 the square root is 5, and I halve the exponent. And then I just put the same thing but with a plus, and there's not anything more that I can factorize there, so I'm finished. I just want to show you a problem where there's a few factorizing techniques combined. Say for instance they give me 16a squared b squared minus 36a squared. Now remember, I said to you in the beginning, you must always first go and see if you can't take out the highest common factor. And here can you see that this looks like difference of squared numbers, and you can even do 16 the square root of 16 is 4, the square root of a squared is a and b, and 36 the square root is 6. So this is actually the difference of squared numbers, but just have a look. 4 divides into both these numbers, so I can first take out 4 and a squared is also present in both terms, so I can also take out 4a squared, and then I'm left with 4b squared minus 9. And then what I'm going to do is I'm going to factorize only this to 2b minus 3 and 2b plus 3. Right, so first always take out the highest common factor before you factorize. I said to you this is exactly a difference of squares even before you take something out. It will not always be, but what would have happened if you just took out, if you just used this rule straight up? Let's quickly have a look at that. If I have 16a squared b squared, I'm using the same problem. I'm just not taking out the highest common factor first, and I write 4ab minus 6a, 4ab minus 6a. Right, now I have this, which is perfectly fine, but there's a common factor 2a that I can take out here, and there's also a common factor 2 out. Whoops, that should be a plus. There's a common factor 2a that I can still also take out there. And what must I now do? You must, because these are not fully factorized yet, so you must take out 2a there, leaving me with 2b minus 3, and you take out 2a there, and not get confused with whether you are multiplying, whether you are dividing, and what's happening here. I can also take out 2a there, leaving me with 2b plus 3, and then I can just group these two loose terms, because this is 4 things multiplied with one another, so it doesn't matter in which order I place them, because 2 times 3 and 3 times 2, same thing. Same with 2 times 3 times 4 and 2 times 4 times 3, same thing. So I'm going to just take the 2a and the 2a and multiply them with one another, and then do the 2b minus 3, 2b plus 3. But can you see there's a lot of potentially dangerous situations and difficult situations that you put yourself in using this method, where this is quite straight up. So it would be better to just check before you factorize anything else. Can I take out the highest common factor and then work from there? Pretty straightforward. Here you can do this, but it opens yourself up to a lot of mistakes. Alright.